Alright, so what we're looking at here is we have cars and trucks that are being built. The car, and we're going to go ahead and document this, the car requires 4 wheels, 2 seats, and 1 gas tank. And if you're going to make a truck, it requires 6 wheels, only 1 seat, but 3 crazy gas tanks. So we have a company, whom we're trying to make this small, easier numbers to work with, but we have our company who has a total of 36 wheels and 14 seats and 15 gas tanks. And what we want to do is to figure out different combinations of cars and trucks that can be created. So what I want to do is I'm just going to start off with, what if I made 0 cars and did just trucks, as many trucks as I possibly could. So the first thing that I'm going to do is I'm going to go ahead and put cars and trucks. And so let's see. Here I need 6 wheels. Well, I have 36 wheels in my my factory, and so I could make a total of 6 trucks. So I look here and I go, well, 6 seats, totally works. 6 times 3 gas tanks, that's too many, that's 18. So I actually can't make 6 trucks. So let's go to the restricting one, which was the gas tanks, and let's figure out the most amount I could make. If it requires 3 gas tanks per truck, I can only make 5 trucks. So let's go ahead and go back. If I made 5, that works. 5 times 6 is 30, so that works too. So, and I used up all of the gas tanks there, so I would have none left over, not even one, to make a car. So that's our maximum number of trucks that we can make. Well, what if we made 4 trucks? If we made 4 trucks, then we used up 12 of the gas tanks, 4, and 24 of the wheels. So I would have 3 leftover gas tanks, so I could make 3 cars. So if I did 3 of this, that would be 6 plus 4, that's enough. And if I did 3 of this, I would have 12, and 12 to 24 is 36. So I could make 3 cars if I made 4 trucks. Well, what if I made 3 trucks? So let's change the math and see what's going on here. If I have 3 times 3 is 9. I'm going to use up 9 of those, 3 of those, and 18 of those. So I have 8 left over. So in theory I could make 8, but I don't have 8 times 2 is way too many. So let's look here. This is 3 of them used up, so I have, what, 11 left over? And so I could make, what, 5? So let's see if I could make 5 of these. 5 times 4 is 20. That's too many. So what if I made 4 of these? So again, we've used up 18, 3, and 9. If I made 4 of these, that would be 16. And 16 plus 18. Ooh, just kidding. 16 plus 18. I'm going to eventually type in the right math here. Okay, is 34. Okay, so we're clear. What did I say? 4. So that would be 16. If I did 4 of that, that would be 8. 8 plus 3 is less than that. And if I did 4 here, that's totally fine. So 4 cars I could make. All right, so let's keep going. If I made 2 trucks, we'll start the math over again, I would have used up 6 of those, 2 of those, and 12 of those, which means I have, what, 24 left over, 12 left over, and 9 left over. So here that looks like I could have 6 cars would fit in there, 6 in there, 6 in there, so that's cool. Let's try 1 truck. Ah, shucks, my truck is stuck. Oh, the book. Alright, let's see, I have 1 truck, so I'm just using 3, 1, and 6, which means I have 30 left over, 10 left over, and 12 left over. So let's see what I can make. I could make, what, 7. 7 times 4 is less than that. 7 times 2, nope, can't do that. So this is limiting. So this would be what, 5 of them that I could make. So if this was 5, 5 times 4 is less than that, 5 times 1 is less than that, so that's good. And then our last one, if we made no trucks at all, what would be the maximum number of cars I could make? So it seemed like this one was our most limiting with the cars, because I need 2 of these, so that would be what, 7? And then 7 times 1 is totally less than that, 7 times 4 is totally less than that, so that would be it. So this is all of our kind of combinations that we can do. So we want to go ahead and plot all of those onto our graph. So we've got this huge mammoth graph here, and we have cars down here and trucks up here. So we have 0 cars and 1, 2, 3, 4, 5 trucks, 3 cars and 4 trucks, 4 cars and 3 trucks. Right, 6, 2, 4, 6 cars and 1, 2, 3, 4, 5 trucks. And no, 6 and 2, that's nice. And 5 and 1, 5 and 1. Wait, that didn't make any sense. If I made 2, if I only made 1, I should be able to make more. So let's look back at that again. I made 6, 1, and 3. This would have been 13 left over. And this would have been 12 left over, and this would have been 30 left over. So 4 times 6 is less than that. 2 times 6 is 12. So I could have put 6 there. And then 1 times 6 is 12. Okay, that's okay. We fix that. So then I want 1 and 6. There we go. And 0 and 7. So those are all of our points. So now we're going to figure out some other things. So first of all, which of these options gives him the greatest profit if he makes $1 on each of them? So really we just look at, this is a total of 7, 7, 8, 7, 7, 5. So the 6 and the 2, because 6 times 1 plus 2 times 1 is equal to $8. Let's look at number 4. 4 says which one gives him the greatest profit if he makes $2 on the car and $3 on the truck. So we're making more money on the trucks, so we want to look for ones that maybe have higher here. So this would be 5 times 3 plus 0 times 2. This is 4 times 3 plus 3 times 2. 3 times 3 plus 4 times 2. And let's see what we have here so far. So this is $15. This is 12 plus 6 is $18. And that's 9 plus 8 is $17. So it looks like we're going to be going back down. So this looks like 4 trucks and 3 cars. Which now let's go ahead and see the rest. If I did 2, because that's 6 is a lot. So if I did 5 times 2 plus 6 times, 5 times 3 times 6 plus 2. This is what, 15 plus 2 times 3. 2 trucks and 6 cars. So that's 12 plus 6 is also 18. So that's also 2 trucks and 6 cars. And then obviously our 6 and 1 is less, but let's try this one. This would be just 7 times 2 is 14, which is a little bit less. So we have kind of 2 options, and both of those were $18 when I did the math on there. Okay, so, and this was a cars and trucks. So let's look at 5. Writing an inequality represents the relationships between cars and the number of trucks and the number of wheels. So we need to go back to what it was that we were looking at here. So for the wheels, we have 4 cars wheels plus 6 truck wheels has to be less than or equal to my total number of wheels in my little area, my factory. For the seats, every car requires 2, and every truck requires 1, and that just needs to be less than 14. And then my gas tanks is every car requires 1, but every truck requires 3, and that has to be less than our 15. So now we want to go ahead and graph each inequality on the graph, which in this particular case, I'm going to go ahead and use the intercept method. So this one here, I'm going to find a 0 for the x and a 0 for the y. So for this, cars and trucks. So if I plug in 0 for this, I get 6. And if I plug in 0 for that, I get 9. I'm going to do the same thing for each of these. So if I plug in 0 for that, I get 14. If I plug in 0 for this, I get 7. If I plug in 0 for the cars, I get 5. And if I plug in 0 for the trucks, I get 15. So we're going to go ahead and graph them all now. So for the first one, for the wheels, it was 0 cars and 6, 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. And so if I graph that real carefully, just barely long enough, I get this. And so everything has to be within my wheels that I've got going on here. So this was my wheels. And now we're going to go ahead and look at the seats. With the seats, we said 0, 7 and 0, 14, I'm sorry. So this was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, all the way up at the top. And this was 7, 0, 1, 2, 3, 4, 5, 6, 7. I need a longer ruler. Okay, so this was my tires. And a lot of them I had extra tires when we were looking at that. And then we have our gas tanks. So for our gas tanks, we had 0, 5, 1, 2, 3, 4, 5. And we had 15, 0, 2, 3, 4, 5. It's a little bit too long. So I'm going to go back here, and I'm going to get it so that my t, which is normally my y, is alone. And so if I divide everything by 3, I get this. So nice, this was 5, and then we're going to go down 1 over 3, down 1 over 3, down 1 over 3. And then we can graph that. So sometimes we can graph them with intercepts. Sometimes the intercepts are a little bulky. You can always go back to graphing them with our normal slopes there. So the thing that I want you to recognize is that each of these original ones, these were kind of helping me graph it, all of the original ones here are actually within this, because all of this stuff is supposed to be less than every single line. So these are all of the different possibilities, because the reality is I could have just done one of each, or 2 of one and 1 of the other, but these would have been kind of my little bit more maximums that I have. So the vertices that I have are 0, 5. And actually I'm going to say this is 0 cars and 5 trucks. And then I had 3 cars and 4 trucks. And I had 6 cars and 2 trucks. And I had 7 cars and 0 trucks. So those are the vertices that I have. So here, what this means is these here are really all of the maximums that I have in one way or another. Everything else is a little bit less. And as you can see, like these are all kind of bumped out at the very maximums. But these are a little bit lesser inside. So these are the only ones that I'm going to need to test now. And so if I have $3 per car and $2 per truck, what I need to do is figure out what I have. So if I have 0 and 5, 3 and 4, 6 and 2, very well, I'm going to do it over here. 0 and 5, 3 and 4, 6 and 2, and 7 and 0 of my cars and my trucks. Now I just need to figure out the cost. So $3 and $2, that would be 10. $3 and 9 plus 8 is 17. 6 plus 4 is 10. And 21 plus 0 is 21. So that would, oh, that's 3 and 2. Why did I do that? 3 times this is 18. 18 plus 4 is 22. So looking at each of these, this one here in this particular scenario would be the most. So that was 6 cars and 2 trucks.